Okay, so now we want to determine if these two lines are parallel without graphing. All right. So the first thing we want to look at is the slope, because parallel lines have the exact same slope. So in order to determine or to see the slope of a line, we need to rewrite these two equations of the lines in slope-intercept form. All right. These are in standard form, but we want to rewrite them in slope-intercept form. And remember, slope-intercept form is y equals mx plus b. M being your slope, or when we rewrite these equations, the term in front of my x value will be my slope. And so the way you rewrite equations in slope-intercept form, you want to simply solve each equation for y. If you're not familiar with solving equations with more than one variable, please see my video solving two-step literal equations. Okay, so I'm going to go through the same process. So I'm just going to rewrite my first equation here, 3x plus 4y equals 12. And I want to rewrite that equation in slope-intercept form to see my slope. So I'm going to subtract 3x from both sides. I'm left with 4y equals negative 3x plus 12. And I'm writing the term with my variable first because I want my equation to look like this. I want it to be y equals my slope times x plus b, or my y-intercept. Okay, so I wrote it as negative 3x because my 3x is negative and my 12 is positive, so that is a plus 12. All right. Now to get this y by itself, or isolate the y, I want to divide both sides by 4. I'm left with y equals, I want to divide each term by 4. So negative 3x divided by 4, I'm going to just leave that as a fraction. So that's just negative 3/4 x. If I could reduce the fraction, I would reduce it, but in this case, it's already reduced. All right. And then 12 divided by 4 is 3. That is a positive 3. So my equation in slope-intercept form is y equals negative 3/4 x plus 3. So my slope in this case is negative 3/4. So I'm going to say that m is negative 3/4. All right. I'm just going to write it right here. My slope for this one is negative 3/4. Okay. Don't have enough space, so I'm actually going to just erase my first equation. And then I want to solve that second equation for y, or rewrite it in slope-intercept form. Okay, same process. Subtract 6x from both sides. I'm left with 2y equals negative 6x. That's a positive 6. So that's plus 6. All right. Dividing both sides by 2. Y equals negative 6 divided by 2. So in this case, I can reduce. That will give me a negative 3x. And then 6 divided by 2 will give me a negative 3. Positive 3. I wrote positive 3, but I put negative 3. All right. So plus 3. All right. But what I want to look at here is my slope, which is the term in front of your x value. My slope, or my m, is negative 3. And so my slopes are not the same. So these two lines are not parallel. So if you were to graph them on a coordinate grid, they will not be parallel lines. All right. Okay, so we have this problem here. We have these two equations, and we want to determine if these lines are parallel. So of course we want to rewrite them in slope-intercept form. So let's go ahead and try this one. I've already rewritten them. So to solve for y, I'm going to subtract 2x from both sides. I'm left with 5y equals negative 2x plus 1. Again, writing the term with your x first. And then dividing both sides by 5. I can't reduce negative 2 over 5, so I simply bring it down. So that's negative 2/5 x plus 1/5. So in this case, my slope is -2/5. All right. So now let's rewrite our second equation. And again, I've already rewritten it to give myself more space here. So I'm just going to simply divide by 10 to get the y by itself. Just that one step. I'm left with y equals, so -4/10 actually reduces to -2/5. 4/10 reduces to 2/5. I bring down my negative. All right. -20 divided by 10 is our -2. But we only need the slope to determine if the lines are parallel. And as we can see, both of these lines have a slope of -2/5. So they are indeed parallel lines.